Technically speaking, technically speaking, I ain't talking vegan when I said that I've been eating, making money on the side, but I use it for the main. I'm speaking in code when I tech talk that financial freedom. Have a seat cause you gon' wanna sit up at my table, yeah. Plugged in that it, girl, IT with the cables, yeah. Network engineering is for you, it ain't no labels, yeah. Shaky with my passion, took a leap, it got me stable, yeah. Now I make 100K or better, paper couldn't fit a stapler, and I spend it on my passion cause I'm capable. Technically speaking, now I'm really talking vegan when I said that I've been eating, I've been technically speaking. Technically speaking, China white.
Welcome to Technically Speaking, where we help you increase your income through tech. Today, we will be examining network apps, devices, and topologies. This is a key element of the Network Plus exam. Completing this lesson will bring you one step closer to passing with confidence and unlocking new opportunities in this tech world. For more resources to help you succeed, check the description for more links to our exam prep notes, study guides, and personalized consultation services. If this video helps you, don't forget to like and subscribe for more ways to boost your tech skills and income. Just a quick introduction to the ones that are new here. Hi, my name is Jessica. You can call me Jess. I am the founder of Technically Speaking. I broke into tech in 2020 as my first job was a voice network engineer. And I thought, wow, if people could learn tech, they would be able to better their financial situation, because it definitely helped me coming from a customer service background. My mission for this lesson is to simplify tech concepts and empower you to succeed. Goal of this exam topic is for you to confidently explain physical and virtual network appliances, the roles the appliances play, and common network functions. This will not only help you with passing the exam, but also aid in your interviewing and troubleshooting skills. Physical and virtual appliances. Physical appliances are the traditional hardware devices you can touch, such as routers, switches, and firewalls. They require dedicated space, power, and maintenance, and are usually installed in data centers or networking closets. These appliances are heavily specialized and are built for specific tasks, ensuring reliability and performance for network infrastructure. Virtual appliances are the software-based versions of these physical devices. They run in virtualized environments such as virtual machines on a server. These offer the same functionalities as physical appliances, but without the need for dedicated hardware. Virtual appliances are more flexible and scalable. They are easier to deploy, manage, and move across environments, making them ideal for cloud-based networks and modern data centers. Physical appliances are hardware dependent and they often offer better performance, but they come at a higher upfront cost and less flexibility. Virtual appliances, on the other hand, offer cost savings, scalability, and the ability to quickly adapt to changing network needs, though they may rely on shared resources, which could impact performance in certain situations. However, networks are evolving and they're growing towards a shift of virtual appliances due to the flexibility and cost efficiency, especially in those cloud and hybrid environments. Router. A router is a critical network device that connects multiple networks together and is responsible for routing data from one network to another. It acts as a traffic controller, ensuring that data packets are forwarded between networks efficiently. Routers use IP addresses to identify the source and destination of data. They analyze these addresses to determine the most efficient path for the data to travel across the network. This process ensures that data reaches the correct destination, even if it has to pass through several networks along the way. Routers are essential for ensuring effective communication between networks, whether it's within a home, office, or across the internet. Without routers, data wouldn't know how to move between different network segments. Switch. A switch is a device that connects multiple devices, such as computers, printers, or servers, within the same local area network. It ensures that these devices can communicate and share data with each other efficiently. Switches operate using MAC addresses, which are unique identifiers assigned to each network device. When a switch receives data, it uses the MAC address to forward it to the correct device on the network, ensuring the data reaches its intended destination. Switches are fundamental in managing data traffic within a network, ensuring efficient and fast communication between connected devices without interference or collisions in that data stream. Firewalls. A firewall acts as a security barrier between internal networks and external networks, such as the internet. It monitors all incoming and outgoing traffic, deciding which data packets are allowed through based on a set of predefined rules. This ensures that only legitimate traffic can pass through. Firewalls are critical for network security because they block unauthorized access to your network while allowing trusted traffic in and out of the network. They prevent potential threats like hackers, malware, and cyber attacks from gaining access to sensitive data or systems. Basically, firewalls just serve as the first line defense for network security, protecting against unauthorized access and ensuring the safety of data within your network. They are essential for both business and personal network environments. Intrusion detection and prevention systems. An intrusion detection system, IDS, constantly monitors network traffic and identifies any suspicious or potentially harmful activity. When it detects unusual behavior, it sends an alert to the network administrator, but it does not take direct action to block the threat. It acts as a watchdog for the network. An intrusion prevention system, IPS, goes a step further than IDS by actively stopping threats in real time. It not only detects malicious traffic, but also blocks or quarantines it, preventing it from entering the network and causing damage. IPS provides a more proactive defense mechanism compared to IDS. IDS is focused on detection and alerting, while IPS takes a more active approach by blocking threats before they can impact the network. Both are essential components of a strong network security strategy. Load balancer. A load balancer plays a key role in network management by distributing incoming traffic evenly across the multiple servers. This ensures that no single server is overwhelmed with too much traffic, optimizing resource use and improving overall performance. By spreading traffic across several servers, load balancer enhance the reliability and availability of applications. If one server goes down or experiences heavy traffic, the load balancer redirects traffic to another available server, ensuring the application remains accessible without downtime or disruption. Load balancers are crucial for maintaining the scalability and availability of services, particularly for high traffic websites or applications. This ensures that users always have access to the resources they need. Proxy. A proxy server functions as a middleman between the client, such as your computer or web browser, and the server, the website or service you're accessing. Instead of directly connecting to the server, your requests go through the proxy, which then retrieves the data on your behalf. Proxies can mask your IP address, helping to protect your identity and location online. Proxies can filter and block malicious traffic, adding as an extra layer of protection to your network. Proxies also cache data, which means they store copies of frequently accessed websites or resources. This reduces the load on the server and speeds up the user's access to those resources. A proxy enhances privacy, security, and performance by acting as a buffer between the user and the internet, protecting users while improving access speeds through caching. NAS and SAN. Network attached storage, NAS, is a file level storage system that connects to a network, allowing multiple devices to access files. It is ideal for file sharing, backups, and home or small office networks. NAS devices are easy to set up and are commonly used for tasks such as media streaming or storing documents that need to be accessed by different users over a network. Storage area network, SAN, is a more complex system that provides block level storage, which is often used by high performance applications such as devices and virtualization. SANs are typically used in enterprise environments where large amounts of data need to be accessed quickly and reliably. SAN storage is treated like a local disk by servers, making it much faster and more efficient for certain applications compared to NAS. NAS is ideal for file sharing in small to medium environments, while SAN is used for high performance data storage in large scale enterprise environments. Understanding the difference between NAS and SAN helps determine the right solution based on performance and scale. Wireless AP and controllers. An access point AP allows devices like laptop, smartphones, and IoT devices to connect to a network wirelessly. It extends the network's reach without the need for cables, providing Wi-Fi connectivity in homes, offices, or public spaces. APs are essential for enabling mobility, allowing users to connect to the network from anywhere within the AP's range. A wireless controller manages multiple APs in larger networks, providing centralized control over configurations, security settings, and performance. This makes it easier for administrators to manage the network, monitor performance, and troubleshoot issues. The controller ensures that all APs are working together efficiently, preventing interference and ensuring seamless connectivity as users move around the network. While AP provides wireless access to the network, the controller simplifies the management of multiple APs, making it essential in larger or more complex wireless environments where scalability and reliability are key. Content Delivery Network, CDN. The Content Delivery Network, CDN, consists of multiple servers located across different regions, known as edge servers. When a user requests content, such as a web page or video, the CDN delivers it from the closest server to the user. This reduces the distance data has to travel, resulting in faster delivery times and improved performance, especially for users spread across the globe. By distributing content across multiple servers, CDNs significantly improve load times for websites and applications, making for the user experience much more smoother. They also enhance reliability as traffic is distributed across several servers, reducing the risk of overloading any single server at any given time. Additionally, CDNs provide failover capabilities, meaning if one server goes down, the content is automatically served from another available server, ensuring content is continued and you have access to it. CDNs are essential for businesses with a global audience, helping to speed up content delivery and increase reliability by ensuring the users can access data quickly, regardless of their location. Common networking functions. A virtual private network, VPN, allows users to create a secure connection to another network over the internet. It encrypts data, ensuring that sensitive information is protected while traveling over public networks like the internet. VPNs are commonly used by remote workers to securely access company resources or by individuals to maintain privacy online. Quality of service, QoS, is a network feature that manages and prioritizes traffic to ensure that critical data, such as voice calls or video streaming, receives the bandwidth it needs for smooth performance. This prevents lower priority traffic like file downloads from slowing down important real-time applications. Time to live, TTL, is a field in a data packet that specifies how long the data packet should exist before being discarded. TTL prevents packets from endlessly circulating within a network if they can't reach their destination. This ensures efficient use of the network resources. These commonly network functions, VPN for security, QoS for performance, and TTL for preventing network congestion, these are all essential for maintaining security, efficiency, and reliability in modern networks. Network topologies. Network topologies determine how devices are connected and how data is transmitted within a network. Each topology has its own advantage and disadvantage in terms of reliability, scalability, and cost, making it essential to choose the right one based on network needs. Let's go over some. In a mesh, each device is connected directly to every other device in the network. This provides redundancy and ensures that if one connection fails, there are multiple alternative paths for data to travel. While highly reliable, mesh topologies can be complex and expensive to implement due to the large number of connections required. In a star topology, all devices are connected to a central hub or switch. The hub acts as a central point for managing traffic. If an individual device or connection fails, the rest of the network remains unaffected, making this topology easy to manage and highly scalable. In a bus topology, all devices are connected to a single backbone cable. Data is sent along this shared cable, and devices listen to data intended for them. While simple to set up, bus topologies can suffer from collisions and are less scalable as the network grows. In a ring topology, devices are connected in a closed loop where each device has exactly two neighbors. Data travels in one or both directions around the ring. If one link fails, it can disrupt the entire network unless there are mechanisms in place for rerouting traffic. A hybrid topology combines elements of multiple topologies, mesh, star, and bus, for example, to create a more flexible and robust network design. Hybrid topologies take advantage of the strengths of each individual topology, allowing for customized solutions to fit specific network requirements. Network types and characteristics. In a peer-to-peer, P2P network, devices communicate directly with each other over a certain authority like a server. Each device can function as both a client and a server. P2P networks are often used for file sharing or small local networks. In a client-server model, clients, connect to a central server to access resources, such as files or applications. The server provides services and manages the network, making this model ideal for larger organizations where centralized control and management are needed. LAN, local area network, covers a small geographic area such as a home, office, or building. It is typically high speed and used for connecting local devices. MAN, metropolitan area network, spans a city or large campus. MANs are larger than LANs, but smaller than WANs. They are often used by universities or businesses with multiple locations in the same city. WAN, wide area network, covers a vast geographic area, such as a country or the globe. The internet is the largest example of a WAN, connecting devices across continents. Wireless local area networks provide wireless connectivity within a LAN, typically using Wi-Fi. PAN, personal area network, connects personal devices like smartphones, laptops, and wearables, usually over a short range using Bluetooth. CAN, campus area network, covers multiple buildings in a limited geographic area, like a university or corporate campus. Storage area network, SAN, a high performance network dedicated to connecting storage devices to servers. SANs provides fast, block level storage access and are commonly used in enterprise networks where large amounts of data need to be stored and accessed quickly. Different network types, from small P2P networks to large scan WANs, they serve specific purposes based on the size, scale, and function of the network. Understanding these types helps to determine which is best suited for the given environment, whether it's for personal use, business, or data centers. Virtual network concepts. A, v- a virtual switch, vSwitch, acts like a physical switch, but it operates within a virtual environment. It connects virtual machines to each other and to external networks, enabling them to communicate over the network just as if they were physical devices. A virtual network interface card, VNIC, is a virtual version of a physical NIC. Each VM is assigned a VNIC to connect to a network through the vSwitch, allowing it to send and receive data just like a physical machine. Network functions virtualization, NFV, involves moving traditional hardware-based network functions like firewalls, load balancers, or routers to a virtualized software environment. NFV helps reduce the need for physical hardware, making networks more flexible and scalable. The hypervisor is the core software that manages the virtual machines and their network resources. It enables multiple VMs to run on a single physical host efficiently, allocating hardware resources like CPU, memory, and network interfaces. Virtual network concepts like vSwitches, VNICs, NFV, and hypervisors are essential for modern, flexible networks. They enable organizations to scale up and manage their infrastructure efficiently without the limitations of physical hardware. Provider links. Satellite communication uses orbiting satellites to provide long-distance network connectivity. It is often used in remote areas where traditional wired connections aren't feasible. While satellite connections over vast distances, While satellite connections cover vast distances, they tend to have higher latency compared to other options. DSL, digital subscriber line, transmit data over telephone lines, offering an affordable and widely available broadband option. Cable uses coaxial cables to provide high-speed internet commonly used in residential and commercial areas. Lease line, a dedicated high-speed connection, provides consistent, reliable bandwidth for businesses. Unlike DSL and cable, lease lines aren't shared with other users, making them ideal for organizations requiring stable connectivity. Metro-optical networks use fiber optic cables to provide high-speed internet within metropolitan areas. These networks are built to handle large amounts of data, making them perfect for businesses, data centers, and institutions in densely populated urban areas. Different provider links, whether satellite, DSL, cable, lease lines, or metro optical, offer varied levels of connectivity. Today, we covered some of the most essential networking appliances like routers, switches, firewalls, and more, as well as critical functions such as VPN, QoS, and TTL. These components are the building blocks of any network, playing a crucial role in how data is managed and secured. We've explored various network topologies like mesh, star, and bus, and network types such as LAN, WAN, peer-to-peer, and client-server. Each topology and network type serves as a specific purpose depending on the size and needs of the network. We've delved into virtual networking concepts like vSwitches, VNICs, and NFV, which are transforming how networks are built and managed. Additionally, we've covered various links from satellite connections to metro optical networks and how they enable connectivity in different environments. Now that you have a foundational understanding of these concepts, I encourage you to explore how they are applied in real-world networks. Whether you're working in a small office environment or large enterprise, or even managing cloud infrastructure. If this video helpful, please take a moment to give it a thumbs up and don't forget to subscribe for more in-depth tech tutorials and networking lessons. Check the description below for additional resources, links to related topics, and ways to stay connected with me on social media. Thanks for watching, and I look forward to seeing you in the next video. Until then, keep learning and exploring the world of networks.